Let's set up some render parameters, quality, and feature options for a standard definition hardware rendering of this simple animation. I've got the camera moving across the space in an arc. If you're interested in high-end production rendering with a global illumination engine, I recommend that you check out some of our other courses, such as 3ds Max Advanced Lighting or 3ds Max Rendering with Arnold. Global illumination, or GI, is a deep topic, and there's no way we're going to cover that in an essential training course. I'm going to render a near production quality image sequence with the Quicksilver hardware renderer. Let's go into the render setup dialog. The target is set to production rendering mode. Let's switch the active renderer over to Quicksilver hardware renderer. We get this substance compatibility dialog. This isn't really important in this case because I don't have any active substance materials on any objects. But just so we don't see this again, we'll click the option Do Not Show Again and click Apply. The render setup dialog refreshes and we can change up some parameters. Previously in the course, in the chapter on cameras, I talked a little bit about the output size of the rendering. In the Comment tab, I've got a small output size, 640 by 360, with an aspect ratio of 1.778. That's appropriate for a draft quality or standard definition rendering. Now let's configure the Quicksilver hardware renderer itself. Go into the Renderer tab. Quicksilver is based on nitrus, the viewport display technology in Max. By default, Quicksilver uses the advanced rendering level, and it always uses the realistic material shading model. Quicksilver is an iterative renderer. It calculates many passes or iterations or layers and puts them all together to achieve better quality. The more passes or iterations, the better the quality will be, up to a point of diminishing returns, at which greater numbers of iterations won't make any difference. Every scene is different, and there's no stock answer to how many iterations will result in a certain level of quality. It depends on many factors, such as the number of lights, the resolution of the rendered frame, and even the exact composition of which objects and illumination are visible within the current frame. For a given number of iterations, the render time is variable, depending on those many factors. If you want, you can set a total time for each rendered frame. If we activate time here, we can plug in a value in minutes and seconds. And whenever that time is reached, the rendering for the current frame will stop. That's helpful because it can tell you exactly how long it will take to render a sequence of frames. But it could result in changes in quality over the course of the animation. So for a consistent level of quality, it's safer to stick with setting the number of iterations. For a near production quality test render, I'll increase the iterations value to 1024 and press Enter. Now we come down to Visual Style and Appearance. I am going to render a realistic rendering, not any kind of stylized rendering. We'll leave the rendering level at its default of realistic. Textures are enabled by default, so we'll leave that on. And transparency is enabled by default as well. Transparency is a bit problematic in Quicksilver because the renderer does not support ray tracing. I actually don't have any transparency in this scene. I do have a window glazing object here, but I've hidden it. Just for safety, I am going to turn transparency off. Scrolling down a little bit, we've got lighting and shadows, and it's defaulted to illuminate with scene lights, with highlights enabled, and that is what we want. We have a slider here for lighting and shadows quality. Usually this slider actually has no effect on the rendering. It's a leftover from an earlier version of Quicksilver. We can leave it at the default of 1.0. We do want shadows to be on, and they are on by default. Also, very helpfully, we have ambient occlusion built in here. This is screen space ambient occlusion that's calculated by the video card. It's a basic solution to give us some contact shadows and darker crevices. Combine ambient occlusion with some environmental or ambient lighting, and you can get a rough approximation of global illumination. I'll enable that, increase the radius up to a value of 10, and reduce the intensity to a value of 0.5. Below ambient occlusion, we'll see indirect illumination. And that sounds pretty cool, but we can't use it for animation. If you enable this, Quicksilver will automatically place some point lights around the scene to give the impression of global illumination. Higher render iterations will result in more lights, giving a better effect of fake GI. But the light positions are going to be different on each frame, resulting in flickering, so we can only use this for still renderings. Going down a bit further, we come to reflections. This is the most problematic part of Quicksilver. The reflection switch should be labeled Reflections from Environment. If we were rendering a single model against an HDRI background environment, this would be great. But in all other cases, it's going to cause problems, especially for interiors. The reflections from the background environment will travel through any occluding surfaces, such as our walls, and we'll get massive hotspots in places we'd never expect. If reflections from environment is on, then you also have the option to generate cubic reflection maps for individual objects. That's what this other checkbox is here. It's not labeled, but it's dynamic scene reflections. And when we enable that, we can then go into this include dialog and choose which objects are going to receive these reflection maps. We can select something and move it over into the other column here. Okay, I'll cancel out of that without adding anything to the include list. Again, this is not ray tracing. It's automatic reflection mapping. The object becomes a camera and takes 6 pictures of its surroundings and then maps those pictures onto the object as reflection maps. Automatic reflection maps have a lot of problems, especially in areas where the objects are too close to one another, and that will cause the reflections to fail. But even if these automatic reflection maps gave you good results in your particular scene, for some unknown reason, we do not have the ability to disable reflections from environment while enabling the dynamic reflection maps. Since those reflections from environment are so uncontrollable, we can't have those on. Therefore, we can't use the dynamic reflection mapping anyway. So for an interior, really, our only option is to turn all of these reflections off, meaning we will not get any mirror reflections anywhere in the scene. However, Quicksilver does respect the roughness parameter of the physical material, so even though mirror reflections are disabled globally, the specular highlights on most surfaces will render fairly realistically. Okay, we can test this out with the physical camera already set up. I've got that chosen here in the view to render, and it's locked. And we've chosen 1024 iterations. Let's click render. The first time it renders, it'll take longer because it has to load in all of the textures and compile all of the material and light shaders. But eventually we'll start to see a progressive improvement in the quality. Okay, that's the result of our draft quality rendering. If we wanted to improve this, we could increase the number of iterations. I should also mention that the quality of the textures here is determined not by the render settings, but actually by the nitrus viewport settings. So if you're getting fuzzy textures, go into your viewport configuration dialog, click the plus sign in any viewport and go to Configure Viewports, and increase the resolution of texture maps and environment maps here. That's how to set up Quicksilver for a draft quality or standard definition rendering.